Hi everyone, welcome to our channel Edupoly Solutions. So Edupoly Solutions is going to launch a new course on a widely containerized tool, that is Docker. So during the course, we will be discussing the Docker, each and every topic in the Docker in detail. Like we'll start with the Docker introduction and we'll discuss about the architecture, installation process, and we'll discuss about the Docker commands and how to create Docker images for any application. And also we'll discuss on the storage networking. And during the course, we'll be giving assignments so that you can practice for the respective topic. And also we'll be performing the real-time project so that you will get a good understanding of the topics that we discussed. And at the end of each topic, we'll be uh, discussing on the interview questions and answers so that you will be well prepared with the interview. Okay, so directly we'll go into the topic. First topic, our Docker introduction. Okay, so you all know that the widely used containerization tool in the market is Docker. So before understanding Docker, we'll try to understand why containers are needed. Okay, then you will able to get a clear understanding on Docker. Okay, so to understand why containers are needed, first we'll take an example. Suppose assume that you have an application to install on a particular server. Assume that uh, you have an Ubuntu server and you have to install one application on the Ubuntu server, Ubuntu Linux machine, which is a Linux distribution. Okay. So to install an application on this, first assume that your application is built using the technologies like Tomcat, a web application, and a MySQL database is used for the application, and you are installing Jenkins on the server to do the continuous integration and the continuous deployment for your application, and you are using Ansible for the as a configuration management tool to automate the some of the tasks in the application. Assume that these are the softwares needed for your application. Now, to install these softwares, we have to first verify the compatibility with respect to the operating system. Here it is Ubuntu. So whether the Tomcat specific version you are trying to install, is it compatible to Ubuntu or not? In the same way, you need to validate whether the Jenkins is compatible for the respective operating system, either Ubuntu, CentOS, Red Hat, anything. Okay. So once the compatibility is valid, then we will plan to install each of the softwares. So to install each of the softwares, you need to install first the respective dependencies and libraries with respect to the each software, right? So that for each software, there will be some dependencies and there will be some libraries, correct? Now, we need assume that you have installed Tomcat, and to install Tomcat, we need Java as a dependent. First, we need to install Java package, and then you need to install Tomcat. In the same way, for Jenkins also, you need Java. Okay. Now, assume that you have installed a specific version of Tomcat. For that, Java 8 version is needed. In the same way, to install Jenkins, a Java 8 version is needed. You have installed the softwares and your application is configured and your application is running fine. So at a later point of time, the requirement came that you need to upgrade the Tomcat version. So when you are planning to upgrade the Tomcat version, again, you have to check the compatibility, whether the Tomcat latest version is supporting the Ubuntu server firstly. And also when you are upgrading the Tomcat, definitely you need to uh, install the dependency packages. That is the latest one. Assume that to install the latest Tomcat server, you need a Java 11 dependency package need to be installed. Now, now here to upgrade, when you are planning to upgrade Tomcat latest version, you have to upgrade the Java package also. But Jenkins is running with the old version of Java. So now what's happening is there is establishing a conflict. So earlier you have used Java 8 as a dependent package to install Jenkins and Tomcat. Now you are upgrading Tomcat now the newest version is not Java 8 is not supported. You have to upgrade the package. So what's happening now? There is a conflict is happening between the dependency packages. This is one of the simple example. In the same way for different softwares, right? When you are installing the softwares, when you are upgrading the environments, there is always a compatibility issues between the dependencies and between the dependencies and also between the libraries. So this is causing an confusion, or this is creating a problem when you are upgrading the systems, when you are installing all softwares in a particular server. Okay, so to avoid this, for example, you have set up this in a dev environment, but you have installed the software, MySQL, Jenkins, Ansible, you have configured the application. In the same way, you have to perform in a test environment. You have to perform all these steps in the production environment. So now what's happening? Every time you have to check the compatibility, and also you have in the setup time is more, right? So you have to follow the same steps in the test environment. You have to follow the same step in the production environment. You know what's happening? The setup time is also is increasing. So to overcome these dependency issues between the softwares and to check the compatibility, to overcome the setup time, long setup time, containers came into picture. Okay, so now what we'll do, we'll install the same application in a container. Okay, now we'll take the Ubuntu operating system. Now what we will do is we will create a containers, so that now you install Tomcat in a separate container, for which you need to install the dependencies and libraries in this container itself, and you install MySQL and the respective libraries you have to install in the respective container. In the same way, Jenkins, the Jenkins dependencies and libraries, and in the same way Ansible. Okay, now what's happening is, irrespective of the version, even if you upgrade the Tomcat version, you have to upgrade the Java version, but it is not conflicting because you are installing all the dependency packages, libraries, everything in a separate container. So this is how the container technology evolved. So when you create a container and install the respective softwares, and in each container, and you will enable a communication between these containers to work your application. Okay, so now you should have a clear understanding why containers came into picture: to overcome the compatibility issues, to overcome the dependency conflicts between the softwares, and to overcome the long setup time. The same application you have to set up in different environments, right? So for that, containers came into picture. This is how the containers. Now you should understand what exactly is a container. A container is a lightweight. A container is a lightweight machine. We can say, we can define a container as, a container is a lightweight, a standalone an executable package, we can say, that includes everything to run a piece of code or to run an application, to install a software, everything. So this is how we can define a container. Container is a lightweight, standalone or executable package to run a piece of code, to run any software, to perform any settings. So everything we can do in a container. So this is how containers are evolved. That is the reason the containers came into picture. Now we will try to understand what is the difference between a physical machine, what's the difference between a virtual machine, and what is a container. So this is very much important to understand about the container. For example, you have a physical machine. Okay, in physical machine, for example, you have like 16 CPUs and 32 GB memory. Using this, you have configured a Ubuntu machine. Okay, you have installed your application. you have installed an application. Your application is needed only some assume 4 CPU and 8 GB memory. Okay, you have installed the application in a physical server. Now what happened? Your application will run fine because you have enough memory and enough CPUs to run the application. But what is the disadvantage here? There is a wastage of resources because your application need only 4 CPU and 8 GB, but you have almost four times the configuration. So obviously what is happening? The resources is getting wasted. So to overcome this challenge, the virtualization came into picture. Okay, so what is exactly virtualization? For virtualization, you are installing an hypervisor on the operating system on a hardware. Assume this is a hardware. Physical server. On this, you are installing a hypervisor. So what happens when you install a hypervisor? When you install a hypervisor, you can divide the, we can divide the physical server into, we can create multiple virtual machines in one physical server using the hypervisor. So now you can say that we can create 4 virtual machines with this configuration. So for that you need to install a hypervisor. Hypervisor is software to perform the logical separation for the physical server. Okay, the same, and now you have 4 virtual machines, right? So to use not only the effective use of resources, there are some many advantages. There are like isolation, separation, the boot time, scalability. So all this comes into picture. We'll discuss the differences between this in few minutes. Just for now, try to understand what's the difference between physical machine and a virtual machine. So to overcome the resources, the main important, we are installing a hypervisor and we are logically dividing the hardware into 4 VMs. Now what we can do, we can install in a particular physical server, we can install 4 virtual machines. Each virtual machines can be of different operating system. It may be Windows, it may be some Red Hat or HCL, it may be CentOS, and it may be some other operating system. Okay, Ubuntu, assume. So in the same, now we can use the same virtual machine. We can use 4 virtual machines to install 4 applications. This is what the difference between, to use the effective resources, we are dividing the physical machine into each. Now what is container? Okay, so container. So in each virtual machine, you have installed a Docker. Docker is a containerization tool, right? We have to install Docker software so that you can implement the container technology. Okay, now you have to install each. When you after install Docker, you can create containers upon virtual machine. Each container you can use to install each component inside the virtual machines. But what exactly is happening when you are creating a virtual machine is using the resources from the physical machine. In the same way, when you are installing a container, when you are running a container on a virtual machine, the container will use the virtual machine resources that is allocated to run the containers. Okay, so this is what in each virtual machine we can run multiple containers depending upon the resources. Okay, so these are to overcome the advantages of physical machine. Virtual machines are created logically, and in a single virtual machine we are trying to install the application, right? But what are the challenges we discussed? The same compatibility issues, dependency library issues, and to overcome the long setup time. For that we are creating containers to overcome that design. So that is now the containers will use the resources of a virtual machine and it will run the containers. So this is like the what the difference between the containers VM and physical machine. Okay, there are some more differences. We can like the resource utilization. This is what we discussed the main, and also we discussed about the operating system. Each only one operating system can be installed on a physical server. But when we create the 4 virtual machines, we can install each operating system, different operating system in 4 VMs. Okay, when with respect to the containers, all containers share the same host kernel, but can have different environments. Environments in the sense like production test, those environments. Okay, and also we need to compare the scalability. When you install a physical server, right? The scalability, it will take like the scalability is limited, we can say, because to increase the configuration of a physical server, again that is a big process. We need to reach the respective vendor. We have to buy the memory DIMMs, okay, and we have to increase the CPU. Okay, the scaling is limited. But whereas when coming to the virtual machine, right? For example, you have created a virtual machine of only one virtual machine here, or 2 virtual machines, assume 4 CPUs and 8 GB RAM and 4 CPUs and 8 GB RAM. So when you create only 2 virtual machines, the scalability is, there is a possibility of scalability, right? If the virtual machine is overloaded, we can increase the configuration of that particular machine. That's why for a VMs, we can say it is scalable. Okay, when coming to the containers, obviously, depending upon the configuration, we can create the number of containers according to our requirement. And coming to the maintenance, right? Hardware maintenance is required. The only for virtual machines, when we see there is no hardware maintenance, only OS maintenance is needed. Whereas with respect to the containers, it is very easy to manage. With respect to security, when you come into the physical machine, right? It is highly secure. And also in the same way, the security will be high. Whereas coming to the containers, right, the security will be moderate, because this is the all the containers are using the same kernel. All 4 containers are using the same kernel. If something happened to this kernel, right, obviously the containers will get affected. That is the reason we call it as a moderate security. Okay. So these are now the main differences between the physical machine, virtual machine, and the container. Now hope you have a clear understanding on what's the difference between physical machine, virtual machine, and a containers. Okay. Now you should be able to clearly understand why containers are needed and what exactly is a container and what's the difference between physical machine, containers, and a virtual machine. Okay. Now, how can we define Docker? Okay. So now you should be, Docker is a, there are many containerization tools in the market, right? There are Docker, Rocket IO, Podman. Okay, there are many containers, but the widely used one is a Docker. So how can we define a Docker? A Docker is a containerization platform that provides easy way to containerize your application. You can containerize your application. You can easily containerize your application. For example, we discussed, right? Your application has a 4 components. Okay, each component you can containerize it. Okay, which means using Docker, right? You can create a Docker file for each container, and using the Docker file, we can run each container on any virtual machines. For example, to create a container, we need a template. We have to create a Docker file. In the Docker file, we have to there will be a Docker file. In the Docker file, you need to create some set of instructions. Okay, this is called as the Docker file is nothing but we can assume like a template. Okay, in the template, you need to create a set of instructions, like which operating system we need to use, how to copy the code, how to run the code, okay, which port you need to expose to run the particular application. Okay, so after creating the template, right, we will use Docker commands to create the image. First, using this, first we will prepare a Docker file using set of instructions. After that, we will create an image using Docker create. Okay, once after creating the image, we will run that. Assume that in the name of the image that you are giving nginx. Okay, Docker ng Docker run. If you run this command Docker run nginx, a container will be created. So how many containers you are needed? In the same way, you have to create a Docker file for each application or each component. You have to create the image and you can run the image. So once you create the image, right, you can use the same image in any environment. So what generally what we'll do is we'll create a Docker file. In that there will be a set of instructions. Using that, we'll create the image. We will create, once the image is created, we will push that image to the Docker repositories. Okay, we'll discuss that, what is actually a repository, what is a public repository, what is a private repository, everything in further classes. So once the image is pushed to the Docker repository, right, we can use that image to install in any operating system. Now you have to install the same container in 4 environments: dev, test, prod, and QA environment. Okay, now you don't need to execute all the instructions at a time. So once the image is created and push it to the repo, right, just you need to execute this command in 4 environments. Automatically the container will be created. This is just an example. Okay, so we can define Docker. Docker is a containerization platform that provides easy way to containerize your applications, which means like using Docker, you can build container images, run the images to create containers, and also pushing the containers to the respective registries, like it's a Docker hub. Okay, this is how we can define a Docker. Now you should, after this explanation, you should be able to understand the difference between container and image. Image is nothing but a template which consists of a set of instructions to run your application. Using this, we will create an image and we'll push that image to a Docker repository, Docker hub. From there, you can run the containers. So what's the difference? Image is nothing but a template which contains a set of instructions. What is container? Container is a running using Docker. We can define a container as container is nothing but a running instance. Okay, containers are running instances of images. So we'll create images, right? Using the image, we will run a container. Okay, now you should be able to clearly understand why containers are needed, what is a container, what's the difference between the container VM and physical machine, how can we define a Docker, and what's the difference between a container versus image. Okay, this is all about the introduction with the Docker. In further classes, we will discuss about the Docker architecture, installation procedure, commands. In detail, we'll discuss each and every details in the further classes. Yeah. Thank you. Thank you for listening. Have a good day.